Hi, in this exercise, I'm going to explain how we can create a linear regression model and get the fitting parameters and predict the data, predict some trend in the data. So for this, I have used some different data, my own data basically. So let's go step by step what I have done in this exercise. So first of all, a linear regression model is the simplest model uh, to predict the trend, the relationship between the dependent and independent variables. By linear, we means it's a simple straight line, y equals mx plus c, and we add here e. E is the error, m is the slope, c is the intercept. So once we get uh, the slope and intercept, we should be able to predict the data value based on the dependent variables. So in this exercise, what I have done, I have used Boston housing market data from sklearn datasets using a linear regression model, and I have used uh, Python coding language. So let's start by importing the necessary libraries. As you can see here, these are the libraries I need to solve my problem in Python. And this is the data loading. So you can see that I'm using the load Boston library. Um, and this is my data set. First, I loaded the data set and started exploring some features in the data set. So I basically do a describe function and I get those descriptions. So you can see that there are multiple attributes like per capita crime rate by town, um, or you can see average number of rooms per dwelling, or let's say number of status of the population, percentage of lower status of the population, and also the median value of the owner occupied homes uh, in in the scale of 1000. So there is no missing attribute, and you can see all the other information. Those are we don't need, but we are interested in these attributes. So once that is done, we do more exploration like the data keys. We see the data keys here and also the data shape. Clearly, you can see that there are 506 data samples spanned over 13 features. And these are the features, these highlighted um, lines are the features. So, um, I think we described the database a little bit. We can see more features of the data, like there are different feature names. I mean, those are the features that I showed in the metadata, the view of the description, data description. Let's see what is the content of the data, and we can simply print the data by importing it into pandas data frame. Uh, and you can see that there are 5 lines, I mean 5 rows of the data are printed here. These are the 5 rows of the data for different um, features. And this is a more uh, descriptive statistical view of the data. Then uh, let's we will print the target variable, and there is a single target variable which is called um, M EDV. That this is the target variable, medium value of owner occupied homes, and just we just put that as a price, rename the column as a price target to be more meaningful on what we are doing exactly in this exercise. Let's print it and we can see those are the examples of the target values. And even we can draw an histogram to see some tendency. You can see the histogram of the target values. And then keeping target value as the uh, independent variable, we can study its dependence on other features like CRIM, ZN. I have drawn the scatter plots. You can see that RM, there is a, as RM increases, the price also increases, number of rooms. And also you can see the LSTAT here. As LSTAT increases, the price gradually decreases. So, what are the features we should choose for the linear regression studies? So the answer is that needs to be determined using the data as well. So what we did is that we create a correlation matrix and to understand and measure the linear relationship that exists between the variables. The correlation coefficient ranges from -1 to +1. And if the value is close to +1, it means that there is a strong correlation, positive correlation between two variables. When the value is close to -1, that means there is a negative correlation. So the correlation plot is drawn here, and you can clearly see that RM, number of rooms, has a strong, has the highest correlation, positive correlation, zero point 0.7, and LSTAT has the lowest positive correlation. So we can say that we can focus our remaining part of the studies on these two variables, RM and LSTAT. So if we replot those variables as a function, price as a function of those variables, then we can see these two plots. Then let's do some data manipulation. Let's go to that level of doing some data manipulation to extract our model features. So in order to do that, um, let us create the test and train subsets of the data. Basically, we are splitting the data into test and train subsets. And in this case, we are using 20% of our data for testing and remaining 80% for the training purposes. And so you can see that I have created the test and train samples, and I I listed some of the test samples. And finally, I have started the linear regression process. And you can see that I have called this linear regression function, and then I simply fit the train samples first. So, and then typically I get this output from there. And then let's calculate the slope and the intercept. This is the intercept, and this is the slope for the, the graphs of price versus LSTAT and price versus RM. These are the these are the slope variables, and this is the intercept variable. So now let us evaluate the model for the training set. So for training set, we define the root mean square error, and let's print the errors. And we can see that for training and testing set, the root mean square errors are, they are practically the same. Uh, it's around 5.5. Then finally, let's apply some fitting parameters, some machine learning that we have learned by fitting it. We using the linear regression model, and then we calculated the predicted price using the linear regression dot predict function. And we also defined the expected price to be the y-axis, the y test, and then finally we did the scatter plot of I mean predicted price versus actual price. And you can see that I have embedded the plot, I mean fitting line as well there. So you can see the quality of fitting. I mean it's qualitative. We don't know exactly the behavior. We can determine that using by deriving the fitting performance. I mean chi-square per degrees of freedom, all those things. However, let's do some prediction uh, for the test data sets, and we can see that we have like these are the test X data set and Y test data set, and the predicted price is 25.5, whereas the actual price is 23.6. So it's close kind of, and the deviation, whatever we see, should be accounted for by the standard deviation or the root mean square error uh, formulation. So that's all. I mean about it. I have learned the basic framework of how to perform a linear regression, how to apply linear regression model to uh, predict some trend in the data, uh, some trend in the independent variable based on its correlation or its dependence with the dependent variables. So those are the things that I've learned in this ICP, and I've used Python language extensively. And I mean, this should be straightforward right now to move on to apply this model to other physical scenarios as well. Thank you.